Okay, so we are going to cover chapter 1 from API RP 580. So the title is nothing but RBI risk-based inspection. So just now we seen, right, total of 17 chapters inside. So we are going to cover chapter 1, that is nothing but a scope. What is the main scope of this particular document that we are going to discuss shortly. So you can see here total 17 sections. So up to here you can feel like introduction only. Then after we can enter into the planning for RBI assessment. So once the plan is out, then you can collect the data and other information, because here it's not like a individual work. So it's like a teamwork. So you need to collect the data from different departments, including the owners as well. And also you need to collect the inspection data, and you can coordinate with the plant operating personnel. So that's why the data collection is very important, and it's not like a single step process. So you need to collect the data time to time. So once the inspection is completed, once the maintenance completed, or once the safety people or operating personnel, so when they give you some feedback, then you need to integrate. So that's why it's like a continuous process, not like just a short term plan. So it's like a continuous process every day, or maybe weekly ones, or maybe yearly ones. You need to collect the data from different set of people, and then you can update your software. You can compile all this data together, then only you will get some conclusions. So that's why the data gathering is a very important step, and you need to link this data to the damage mechanisms and failure modes that frequently occurs in the similar industries. So sometime maybe if you're operating 5 6 plants, so in one plant you got some accident, or you got some kind of special damage mechanism, immediately you can collect some data from them, and you can try to update your system here. So you can take some experiences, and you can assess your current situation as well. So then once you got this data, then you can start assessing your probability of failure. This is what we call as a POF, probability of failure. Then the next one is a consequence of failure. So if your probability of failure is less, then you can plan for like the other activities, like you can avoid the near future accidents. Like even though there is a very less risk of failure, but still you need to have some action plans if in case. So if in case something went wrong, so what is your next immediate actions? For example, you see the crisis, like economic crisis in some countries, immediately the other countries used to take some precautions, so to avoid inflation, all these things. So they'll take some steps in advance. The same way here also, we need to have some contingency plans, like a COVID time. So some countries, what they just ignored in the beginning, but what happened, they taken the risk, and they didn't put any protocols in the initial stage, and they seen many fatalities. But once they seen the consequence of failure, the opposition from the public or from other departments sometime, so they'll start the immediate steps, but already the damage occurred. So that's why sometimes the timing is very important. When you are taking the steps is very very important. Then the risk determination, assessment and management. So that's what, when you got some idea on this, immediately you need to plan for this management. So you need to take the negative thinking also here. So not always a positive thinking is beneficial. Sometimes negative thinking is also helping the asset integrity team. So they will think like, what happens if the failure occurs to our plant also, the similar damage occurred to our side. For example, you seen this nuclear power plant Fukushima. I think in Japan there was a one nuclear disaster, like because of the tsunami, so that plant entirely got damaged. But that kind of tsunami may not occur in US, but still they will take some lessons from that particular accident, and they'll take some precautionary steps in advance. So they'll try to put more restrictions, or maybe more safety oriented protocols. So these are all like the lessons that we can learn from others failure as well. That will give a good information, because we are not facing the problem, and we are not going through uh, that bad times. So there is no loss of production, there is no loss of containment, and there is no reputation damage, right? You can take care of yourself in advance. That's the meaning of this assessment and management. And mitigation. So risk management with mitigation and some inspection activities. Sometimes you need to increase the inspection activities. You need to increase your inspection budget. You need to go with some inspection audits or some instead of going every 5 years inspections, maybe you need to go for every 3 years once, because already you've seen some accidents because of that lengthy inspection intervals. So that's why here you need to reduce the inspection intervals. Sometime maybe you can implement some new technology, because the old technology, outdated technology haven't revealed some defects. If you see the aircraft crashes, the engine failures, most of the time they'll end up with these kind of reporting. Like they'll say like the technology missed it, or maybe the entity or the inspection company missed out this, or maybe the codes or the standards not covered that particular item. So they'll come up with some conclusions and immediately they will update this inspection requirements. So other risk mitigation activities. So that's why you see the aircraft industry last time what they did. So every passenger must undergo the COVID test, the swab test. So 48 hours before they need to have a negative report. Then only they will take on board, right? So these are all like some mitigation activities. They try to at least minimize. If someone having already positive results, at least they'll stop denying this that particular passenger. They can protect other people, because not every time we face the same scenario. Like sometime maybe you may have old passengers or infants, so if they get attacked, so maybe the consequences are very severe. So that's why they'll try to mitigate, they'll stop other passengers who are all having the positive. So something like based on that scenarios, you can take immediate mitigation activities. Then reassessment and updating the RB assessment. So time to time when you collect this feedback, when you got the data, you can update it, you can reassess. So like as you see in the COVID time, so when it is a second wave, third wave, like when they got the new variants, so when they got some data, then immediately they'll update, like they saying that this virus is not that much dangerous. So by just taking some simple precautions, we can avoid the fatalities or any hospitalizations. So sometime when you have enough data, you can take the other plans, contingency plans. And roles and responsibilities, training and qualification, because this is trying to help the asset owners to increase their lifetime, like to increase the lifetime of the components or their assets, and reducing the catastrophic failures, and also increasing the inspection levels. Ultimately they are trying to help the asset owners. So that's what like they always used to engage the qualified people, and sometimes they'll give the training to their operators. Sometimes they bring the expertise from outside, and they will get trained the technicians. Sometimes you see the API courses and all. We used to visit the plants and we give the training for API 510, 653, 570, but they will not go for any examinations. But why? They will attend all these sessions to familiarize the requirements, to understand the requirements, so that they can easily control the API inspectors and other entity operators, and they also can understand the reports. So when the AP inspector gives some recommendation, so the management people also will get a clear understanding of its outcome. So that's why the training is always important, and qualifications also important, like when they engaging the entity companies or API companies, inspection companies or third parties, so they can evaluate in a better way. So they always recruit a qualified technician instead of just recruiting someone with some recommendations. And finally, the documentation and record keeping is very important, because it's not like a 1 day program or 2 days program. It's a like continuous process. That's why most of the time they'll keep the servers and the software, and they used to update time to time. So what is the initial thickness, and what is the thickness after 5 years, and what was the inspections they did. Same like a hospital medical history. If you went visit your family doctor, so they used to keep all your records. So including the blood test reports, so the diagnosis reports, so all those are height, weight, and they'll monitor everything in detail. Or another best example is a pediatrician. So you see the by from birth to at least 1 year, 2 years, the doctor will maintain the entire data, including the vaccinations, including the growth, like 3 months, 6 months, 9 months, 1 year, 1.5 year. So they'll maintain all that tracking, so that they can tell the growth of the baby easily, right? So whether it is going in constructive manner or anything deviating, so immediately they'll plan for medications, right? So that's what the documentation and record keeping is more important. And finally, the summary of risk-based inspection pitfalls. So even though you have a very good plans, but sometime we may face some issues. Even though you see the US economy, so they may feel like they are like pioneers in the business, trade, everything, but sometimes you see the bankrupts, the, the collapse in the bank system, and the value of the dollar against the other currencies, and sometimes the wars, the consequences, and also the sudden kind of diseases like COVID, all these things, everything is impacting the whole, right? So there will be some pitfalls. So that one also they discussed here under chapter 17. So now we are going to cover chapter 1, that is nothing but a scope. So in this, they are just trying to motivate what is the main intention of this APRP 580, and which group of people will get involved into this, and what type of assets we can cover, or which type of equipments we can cover as part of this RBI program, and which equipments do not really requires this RBI involvement. Okay, so that is industry scope. They started with industry scope. The first one, although the risk management principles and the concepts that RBI is built on are universally applicable, this recommended practice is specifically targeted to the application of RBI in the hydrocarbon and chemical process industry. So what they're trying to say here, you can apply this RBI in any place, even in your personal career or even in your personal life. So everywhere you can apply this RBI, you can assess the risk and you can take the next decisions. So but here this API RBI is based for these two industries. One is a hydrocarbon, then the next one is a chemical industry. So most of the time we can say like petrochemical industries, petroleum and chemical industry, or we can say hydrocarbon. Hydrocarbon, petro is nothing but based on carbon, hydrocarbons, C and H. So that is what we call as a petroleum industry. And this one is a chemical. So chemical like pharmaceuticals or biological or any other chemical industries, medical industries, all. So combinedly we can say PC, petrochemical industry, petrochemical. Okay. So we can say oil and gas, but we try to memorize like a PC, petrochemical industry. Petroleum is nothing but hydrocarbon, or you can say oil and gas industry, and chemical is separate industry. Okay, you can see we can say like hydrocarbon processing industry, petrochemical and chemical. So there is one exam question on this statement. So RBI is applicable mainly for hydrocarbon and chemical process industry. So they just mainly targeting these two industries. Then coming to the flexibility in application, so they haven't mentioned only like you can apply this particular document only for Shell, only for Saudi Aramco, or only for Qatar Gas. There is no like such restrictions on the company size. So you can see a broad diversity in organizational size, culture, and federal and are all local regulatory requirements. You can apply this document in US or in Saudi Arabia or in India or in Singapore or even in China, Japan. But when you see in like some countries like China, South Korea, Japan, so they may have the other models. So the Japanese may have their other stringent models. They may not require to use exactly the 580 recommendations. So it all depends on their needs. That's why in the beginning introduction they clearly mentioned. So based on your needs, you can implement. It's not a mandatory requirements because it's a recommended practice. They're just providing the recommendations. So that's why what they're trying to say here, this document can be applied to organizations of any size, any culture, any nationality, or any government regulations, whether it can be US federal government or maybe Indian government or Saudi government. So you can use anywhere. So most of the time, if you see the Asian countries and Gulf countries, they may adopt all these API standards because most of the time they have a good relations with the US government and they used to implement similar documentations. That's why you see most of the time we'll see ASME requirements, API requirements, then SNTTC 1A. So all these why we are implementing because of these close associations. But if you see Chinese government and Japanese, so they may not use all these things. And if you see Europe they have other requirements, European norms, ENISO standards. They may not use these API requirements or ASME qualifications. They may have their other regulations like pressure equipment directives REN ISO 9712 qualifications. They may not follow SMTC 1A. So it all depends on their special needs. Okay, that's what they're saying. You can apply to any country, any local or international regulatory requirements. And this recommended practice offers the users the flexibility to apply the RBI methodology. So when you enter into the chapters, so you can easily understand the consequence of failures, the probability of failure. You can plan the risk assessment for your company, and even for your personal career also you can apply this risk matrix. That's what they're saying. You have a lot of flexibility in applying this RBI methodology. So within the context of existing corporate risk management practices and to accommodate unique local circumstances. Sometimes you see the layoffs, especially in a US government, if they want to remove the software employee, if they want to remove a local person, it's very difficult because local labor laws and the compensation policies, all those things. But if they want to remove a foreigner, very easy. They just give a notice period 1 month and they'll just compensate and they'll settle the technician easily. But if they want to remove the local technician, very difficult because of the policies involved. So that's what they're trying to say here. Like the corporate companies or the asset owners, they can prepare their risk management practices and they can implement in a strategic way. Okay. So the document is designed to provide a framework that clarifies the minimum and recommended attributes of quality risk assessment without imposing undue constraints on users. So they come to know what are the minimum requirements. Like if you want to prepare the risk assessment, so you need to list out all those factors that contributing to the probability of failure. Like for example, if you imagine an IT company, so the probability of failure, probability of removing the technicians is a like not having enough orders, no projects, and maybe the operating cost increased, and maybe the government imposing on the foreigner technicians only need to use locals, the operating cost increasing, no cheaper labor, sometimes the COVID restrictions, work from home, so many things that they can contribute to this probability of failure and the consequences. So they can save money, right? When they remove the technicians, when they remove the foreigner workers, they can save little bit money. But if they remove the local people, so they can save huge amounts because they no need to contribute to the insurance or medical or any other provident funds. So they can save a lot of money, but the problem is the reputation. Maybe the opposition from the government, opposition from the public. So that's why sometimes the corporate they still take some risk. They'll keep so the local staff, even though they feel like they are not worthy, but they'll maintain the local staff because to comply with the local regulations. So that's what they're trying to say here. Like you can get a framework how to implement all these risk-based management schemes. So this recommended practice is intended to promote consistency and quality in the identification, assessment, and management of risk pertaining to material deterioration that could lead to the loss of containment. So what they're trying to say here, time to time, you need to check for this material deterioration, meaning the type of damage mechanisms, type of the threats. So time to time, you need to monitor, and so that you can avoid this loss of containment. So what they're trying to say here, like try to monitor your industry, then you need to keep the minimal staff to comply with the government regulations. The same way here also, like you're trying to mitigate the consequence of failures. Even though the recession occurred, but you are still maintaining your company. You are not closing your company. So that is what that indirectly saying here. So you are mitigating this probability of failure and also the consequence of failures. So how you are doing this? You are trying to identify the risk in advance and you are trying to assess it. So you are taking some precautionary steps. Maybe you are trying to reduce the salaries. So last time during the COVID stage, what they did, so they instead of removing the technicians, they try to reduce the salaries. They try to pay the minimum salaries, no overtime, nothing, no allowances. So just try to give the base salary. So once the situation improved, they used to give the allowances, incentives, right? They try to motivate the team. So the same thing occurs here. Like you need to assess the level of risk, identify the risk, and assess it. Then management of the risk. Best example, when you are going for an inspection inside a confined space. For example, you want to do some inspections inside a storage tank. So you need to have a risk assessment in place. So your safety people, they need to do the gas check and they need to ensure the proper ventilation, lighting, everything. Then only they'll give the permit. And time to time they'll monitor the gas levels. Then they will allow the inspection to team to work. And sometimes they'll stop other activities like welding, other incompatible works inside. Right? These are all like a part of your assessment and managing the risk levels. So that's why risk assessment very important if you want to execute any works inside a plant. That's why most of the time these activities were performed by your HSE department. So you can see here loss of containment, like suppose sometimes like poisonous gas is leaking, so they may have some gas detectors in the near vicinity. They'll produce alarms like safe detectors, like fire alarm detectors, all those things. Okay, so they want to have a better understanding of the entire plant, and they used to keep all the detection devices. And yeah, okay. So what they're trying to say here, like you're trying to minimize these leakages. So in the plant, whether it can be a gas or any liquids or any poisonous chemicals. So sometimes you may think like the leakage is very small in quantity, like only one drop leaking, two drop leaking. But the problem is with the associated factors, like if the oil is leaking or the gas is leaking near the smoking area. So what happened? That is an approved smoking area, people used to smoke. But when the gas leaks, so it catches fire immediately because of the flash point, because of the ignition mixtures. So all these things we need to take care in advance. So that's what they're trying to say here. So you need to have a complete picture of your assets in advance. And this RBI document will also help you to understand all your local requirements, like local government regulations, requirements. So not only like one country. So when you're operating the plants in several countries, if you see US companies, they may have branches or they may have their uh, like branches in other countries, or like one particular product they'll produce in US, but other associated things they may have plants in Taiwan and China and India. So like they'll get a different ingredients from other areas and they assemble it in US or in China. So they want to reduce their operating costs. They may have several plants. So all they may be like interconnected. So you may need to have a feedback from other branches as well. So that's what they're trying to say here. If you implement in different places, so you can get a better understanding of entire system as well. So many types of RBI methods exist and are currently being applied throughout the industry. So you have variety of methods. So API RP 580 is not intended to single out one specific approach as the recommended method for conducting an RBI effort. So not like a single mechanism. You can use a different approaches. So different countries they use a different strategies. Best example like during the COVID time. So some countries they use like a sampling. So they'll take one area and they'll just do random samplings. But some countries they'll ask everyone to take the swab test. But some places like African or Asian countries, some countries no test at all. They just ignore the people, like because of the lack of funding or the government policies, and people also not supportive sometimes. So the RP instead of intended to identify and clarify the minimum essential elements of an RP analysis and program, as well as to provide guidance on the recommended work process for conducting a successful RBA program. What they're trying to say here, like when you read the next chapters, you will get a clear guidance. So they are guiding you how to implement or how to create this program and how to implement and what are the problems that you face and how to collect the data and how to update and how to reassess. So everything step by step they detailed in the following chapters in addition to these minimum essential elements. So the best RBA program will not only be in compliance with the minimum essential elements in this recommended practice, but will also adhere to the entire work process contained herein. So we are not disturbing others. What they're trying to say here, like you may not disturbing other teams, like for example operators, like a plant operators. So they are operating and they are collecting the data. Maybe you are just asking them to collect the data more frequently. Like last time, every 6 months they are collecting the information. Now you are going and asking or requesting them to collect the data every 3 months once, so that you can get more information to take the decision, like a medical test. Last time, every 6 months you might have taken the blood test, but now your doctor suggesting weekly once you need to take the blood test or sugar test, so that they can control the things in advance. So that's what here they're saying, even though you are covering the minimum essential elements, sometime you can adhere to the entire work process content here, meaning you are closely monitoring with the operating personnel or AP inspectors. So sometimes you are closely traveling with them and collecting more additional information. So you can apply this RBI to either refining petrochemical plants, chemical processing plants, oil and gas. So almost giving a similar meaning. We can say like hydrocarbon and chemical industries. So it's a combination of assessing the risk assessment. So you can see a risk assessment process and you can give the risk ranking. So if they are within the limits, then you just ignore. But if you feel like something is a high levels of risk, like a sugar levels, deep blood pressure levels. So when you do the testing, so when you notice the high levels of this, immediately the doctor will suggest you to take some changes in your diet. So they will ask you to do some exercises, everything. So these are all like some actions to mitigate. And also he may set an inspection plan. He may ask you to visit more frequently to the hospital and give some samples, all these things, and some mitigation. So he may ask you to stop eating certain items because the cholesterol level is high, the blood pressure is high. So sometimes they may suggest some actions to mitigate the risk levels. And once you implement all these things after 6 months or after 1 year, so he may go for a review. So he will say last time very high blood pressure, but now you change your life habits, food habits or sleeping habits, all these things. Now everything comes under normal. So these are all like a reassessment, and they used to maintain all these data time to time. So what happened on the first day, what happened on the third month, 6 months, 9 months, 12 months. So they can have a review and they can update the records. You can see a sampling plan and AQL. Sometime you may need to have additional data. So that's why you may need to go for some sampling plans and switching the rules. So instead of going for monthly ones, maybe now you are going 15 days once. So like exercises, last time you only did brushing in the morning, but now you are doing brushing both the morning and evening because of the doctor suggestion. So sometime when the doctor suggests, so we may change certain things. So the same way here also, when the RBI team suggests, so they may collect more data or more frequently. They'll do all these assessments. So that's why this is like a planned steps, not like just random suggestions. So based on the data analysis, based on the feedback and based on the case study, so they'll suggest all these things. So that's what the documentation is very, very important. You see here everywhere they're saying the documented methodology, documented method for consequence of failure, documented methodology of managing the risk. So everything is written on the paper. So the reports, the diagnostic reports or the test reports showing the results. So based on the improvement, then we can avoid the frequent inspections. So main approaches for data collection is a qualitative, like a rough data, and quantitative and semi-quantitative. Qualitative means sometime maybe when you visit the doctor, he will ask what are the symptoms, how you feel, like your sleep levels. So he may ask some information. So you can say verbally, that is like a qualitative information. But sometime he may need a quantitative data. So before seeing the doctor, so you may need to give some information like your height, weight, the blood pressure details. So some nurses will collect all this data and they'll pass to the doctor. Then he can see all this information in numbers. That is what we call as a quantitative data. So most of the time here we can say like a statistics or numbers or like remaining thickness or the current corrosion rate. So all these quantity numbers. So they'll check with the reports like API inspection reports or NDT reports they'll use. And sometimes it is a mix of these two. Then the next one, mechanical integrity focus. So all this assessment is completely based on this asset integrity. So they try to ensure your system is working properly. They are trying to ensure your body is working properly as per design. So like there is no disturbance in the system. Like for example, if you see some patients like the dialysis, like a kidney is not functioning properly. So when they treat the patient, so after a few months, maybe the kidneys starts functioning in a normal way. So that is like a kind of integrity, mechanical integrity, meaning that particular equipment need to work in its 100% way. Like it should not show the lesser performance. So it should give its performance to the 100% level. So that's what the RBF process is focused on, maintaining the mechanical integrity of pressure equipment items and minimizing the risk of loss of containment due to deterioration. So the main intention is, even though there is a loss of thickness, like for example, last time the pipe is 10 mm, but now it becomes 8.5, but still you are operating at the same level of production. So you're not compromising on the production levels. But what you are doing, so you are collecting the data, you are taking the thickness measurements, and you are doing some corrosion rate calculations, and you are maintaining the same IOW integrity operating windows. So you are maintaining all these things, then you are maintaining the equipment also, like you are not damaging the part, you are not giving a chance of loss of containment. So even though there is a loss of thickness, but you are not compromising on anything. So you are inspecting, only the thing is you are spending some extra time on the inspections or on the on-stream inspections. So without stopping the production, maybe you are engaging some corrosion mapping or thermography or vibration analysis, you are collecting some data and you are giving the assurance to the owners to operate. So that's what they're saying, like you are giving the assurance there is a like a minimal chances of loss of containment even though there is a wall of thickness. So you are saying there is no issue, we can operate. But when you found some cracks, so then the things will change. So you are stopping the plant, you are asking them to do a repair immediately, because when you operate at certain pressure, the crack may propagate and leads to failures. So that's what here the RBI comes into picture. So based on the inspection reports, so they will take some decisions, bold statements, bold decisions they will take. So RBI is not a substitute for a process hazard analysis or hazard and operability assessment. Sometimes you may think these are all like regular risk assessment. Maybe your safety also will check all these things, but it's not like that much technical. So it's not like in detailed analysis. That's why, so there this risk-based inspection is not a substitute for your process hazard analysis. Just by having RBA report, you cannot avoid the basic safety concepts. So your safety department, they need to do their own assessments. So you're not a replacement for some departments, even though your work is matching that particular requirement. For example, you see the central force and a state police department. So you have a state police, you have a central force, and sometimes you have a national security guards like NSF or some special commandos. They, why they maintaining all these special task force, all these things? Why? Because they cannot uh, they cannot give the assurance. So sometimes maybe some unexpected things may happen. So that's why like RBI is a such kind of thing. So you need to have the team in place and they'll give the guidelines like intelligence department. So they'll just monitor and they'll give the data to the states so that they can alert the local people. Right? Sometimes the weather departments, so they may assess and they'll tell the governments in advance. So there may be a chances of tsunami or some kind of earthquakes. So they will alert the people in advance. So that's a kind of RBA. It's not like the local departments not working in full. So you have some departments over them and giving a better information and better production. That's why RBI is not a substitute for this process hazard analysis and hazard operability assessment. So in the next chapters, you can get a better understanding of these two items. Time being, you just think like those are all like some strategies so to implement in your industry. So process analysis form. So you may have all these forms in place and you can check what type of equipment you are operating and what are the safety issues. So does it have a utility systems or any new jobs, or we have any like adequate facilities, adequate manpower, all these things you can assess. So you may use some checklists and time to time you can ensure all these things. And the next one is a hazard operability assessment. You see here, so your chemical industry is a dangerous thing. Pharmaceutical also, we are dealing with some chemicals, and oil and gas, same thing. Petrol, diesel, and nuclear industry completely dangerous. But still, we are operating the nuclear reactors. We are having the refineries. We are also having the pharmaceutical industries. Even though they pose some threat to the human beings, but still we are operating all these things. How we are doing all these things? By mitigating the risk levels, by assessing the hazard levels. So as long as if you maintain the safety requirements, you can keep all the risk levels very low. So you can reduce the hazard levels very minimal. See, nuclear plant, best example. Even though the nuclear is a very dangerous, but still we are operating the plants. How we are doing this? By taking 150% or 200% safety measures. So you can see here, so they use all these mitigation strategies and reduce all these failures. So the next one, so typically PHA risk assessment focus on the process unit design and operating practices and their adequacy given the unit's current or anticipated operating conditions. Same like a patient in a ICU. So based on the condition, the doctor will respond. For example, if the patient condition is not critical, so they'll just instruct the nurses to give the required medicine time, right? But if the patient condition is very critical, so what happens? The specialist will come down and they will take care of the patient. Sometimes if this guy is a celebrity, so you can imagine like many specialists will come down and continuously monitor. Every half an hour they release the bulletin to the media saying that okay, so being monitored by the specialists, right? So the same thing, like you are checking the current or anticipated operating conditions with the help of these risk assessments. So most of the time we use these kind of charts or risk assessment tables, and timely they will update and they can assess the risk levels. So you can see time to time they can check the status. If you see the ICU, so you can see the dashboards or you can see the echo patterns, all these things. Based on that they can assess the patient condition. Okay, so this is what we call as a process hazard analysis. The next one, RBA is not a replacement, but how it helps this PHA. So it complements the PHA. So it's like an expert's advice. So when the expert are given some advice to these local doctors, they can give it try and they can yield a better results. So sometime if you've seen the celebrities issues, medical issues, what they did, so they got some information from the expert from the overseas. So they'll say they talk to the US doctors and they got some information and they are trying some new medicine or maybe new injections or they are trying the new diagnostics. So sometimes they have a collaborations with the expertise from the overseas. So that's what they're saying here, like RBA is a complement with the process hazard analysis by focusing on the mechanical integrity, related damage mechanisms and risk management through inspection. So sometime maybe the expertise will suggest, okay, you take this particular test. So you send for some additional tests. So get the data and analyze it. So if you found something wrong, then immediately you can take these precautionary steps so that you can minimize the risk levels. Sometimes you see this COVID test. So not only like a swab test, so they may take some other additional tests. So if the test is positive, then they may take some additional vaccinations or maybe some medication so that they can control the patient situation. Same way here also. So you can take some suggestions from RBI. You can try to mitigate this risk levels. So that's why they say RBI is a complementing the PHA. This is also an important question in the examination. So RBI is a complementing, not a competitor or not a replacement or not a substitute. It is complementing. So both together will yield better results. So you can see here like you can mitigate by combining this PHA with RBI. So you can mitigate. So you can bring down the risk ranking levels to a lesser level. Last time patient is in critical condition, now he is in a stable condition. You see best example, last time we had some vaccination. So when they bring the vaccination from some countries like Germany or some places like a Pfizer kind of thing, So when they given, so the patient's condition got stabilized. So they responded very well to this vaccine and they reduced the fatalities. So some kind of like immediate strategies also will help to bring the risk levels to very low levels. Okay. In addition to that, we also have another program is a RCM program. RBI is also a complementary to reliability centered maintenance programs. So like RBI is helping the maintenance programs also. So you need to have an idea about this reliability centered maintenance. So meaning your maintenance is mainly focusing on the reliability. So best example, if you see some service stations, especially the branded service stations. So when you send your motor or your equipment, your car to that particular center, so they will give a good results. So you can give, you can have a 100% assurance. So saying that they will do a proper job, the response is very good, the customer service is very good, they can maintain a good level of quality and standards. Best example, you see the, one second. So you see best example your airlines. So when you book a flight ticket, so they will make you satisfied with their food. So whether you are a vegetarian or non-vegetarian or infant or old person or a drinker, smoker, anything, like they will try to satisfy in all aspects, especially if you took a long flight, right? So like a kind of reliability centered maintenance. So you don't need to tell them anything. So if you ask them, they can provide whatever you want, right? So that's what here the reliability centered maintenance, meaning when you call this maintenance department, so they will fix your issue, so it will not get repeated. So most of the time the maintenance department, they used to keep an experienced technicians. So it can be like your air conditioner technician or electrician or even a normal cleaning department technician also. But when you got some issues like a choking issues in the drainage line, or maybe the engine issues, or maybe power failures, tripping, so anything, when you call this maintenance department, so they fix it within less time. So they will not waste your time, and at the same time they can provide you a quality of work. That is what we can link with this RCM, reliability centered maintenance program. In that, both programs are focused on understanding the failure modes, addressing the modes, and therefore improving the reliability of the equipment and process facilities. Sometimes you see the nurses in the hospital, they'll just quickly diagnose. So they just follow the doctor's instructions, immediately they'll rectify the scenario. So they'll give the saline or they'll give the necessary injections, they'll monitor and they'll bring the patient's conditions under control. So that is what we can say like a reliability centered maintenance. It is a combination of all these things. You can see it can be a reactive, interval, or CBM, or like a condition monitoring, then proactive. So reactive means like instantaneous, like sometime if the patient comes to the emergency department, so what they do, immediately they'll respond. They don't bother about the condition of the patient, whether they are bleeding or maybe many injuries, broken legs, all these things. But what they do, they'll respond timely and they will do the necessary treatment. So that's why they should be mentally strong enough. If you see the hospital cases all, so that emergency department people, they are totally uh, exceptional level. So the doctors also like they will stitch like a bags stitching kind of thing. They don't think they are like patients and they stitch like a bags, and then they'll send to the next department, then they'll do the fine surgeries. So these are all like part of their strategies. So small items, non-critical, unlikely to fail, redundant. So sometimes if it is not a emergency, they'll refer to other department. So sometimes if it is immediate, so they will take proactive steps. These are all like the steps involved under reliability centered management, but at this moment under chapter 1, so not required to go in detail, but other chapters they'll give more detailed information on this. So what are the benefits of this RCM? So safety is naturally prioritized. Focus on continuous improvement increases reliability. So next time when you call this technician, you will give a compliment saying that yes, this guy will come and he will fix it immediately. You can give a recommendations also. But when this team fail, so what you will tell? Okay, you will always give a negative ratings, saying that okay, this technician they don't fix the problem. Always they're repeating the same problem. So optimization brings a cost reduction. So if it is a repeated failure, every time you are facing the same issues, like for example tripping of your electrical connection, so what you do, next time you can change the switch ports, or maybe you can purchase branded equipments, and you can avoid this repeating mistake. And targeted interventions lead to efficiency improvements. So sometimes if they think like the operators are not competent enough, next time they'll replace these technicians with a highly competent operator so that they can minimize the failures. You can see here, so you can ask these 7 questions when implementing this RCM. So what type of equipment, what are the functional failures, and what are the failure causes? For example, if it is a voltage regulations, voltage variations, fluctuations, so what you can do, you can purchase a voltage regulator, you can fix it so that your UPS will maintain this equipment, so you can avoid frequent failures. And effects of failures, what went wrong, so like sudden failure of your electrical equipment or sudden failure of gas supply. If you imagine hospital, so if suddenly failure the power supply, so the oxygen supply got disturbed and patients lead to fatalities. So the consequences, prevention, how you can prevent, you can have a backup like a battery or UPS, right? Then backup plans. So these are all like not like a single step, so you need to assess all these things. So what exactly required basically, so in order to have this reliability centered management system, you need to have these programs in place like asset condition information, and also you need to implement this condition monitoring techniques like a vibration analysis, ultrasound testing, and NDT, and motor testing, and machinery lubrication, then fluid analysis. So like what they're trying to say here, like by collecting some data, immediately you can assess the condition. Like maintenance people, what they do, they'll check at 2 3 locations, they can easily diagnose what went exactly wrong. So especially if you see the electricians, they put their tester at different locations, they'll collect some data and they will assess what went wrong, immediately they fix it. Okay. So that's why here it's a combination of preventive or reactive or predictive. So that's why you got this PDM techniques, predictive maintenance. So you can use infrared thermography. So you can check where the loose connections are, where the loading is going very high, or where you got the pairing issues because of the lubrication problems. Or you can use a vibration analysis to assess the condition of misalignment or condition of the motors. So then next shutdown, you can fix all these issues in advance. So you no need to wait for the catastrophic failure. So you can collect the data and you can fix all these issues timely without calling for any sudden shutdowns. So RBI is also complementary to this. So just now we mentioned, right? So what are the equipments covered under this RBI program? So the following type of equipments and their associated components are internals. So not only that equipment, also the associated components, nearby equipments. For example, if you are dealing with a pressure vessel, so immediately you have this PRDs, pressure relieving devices. So they also covered as part of this, and also internals, because like internal components. So you are dealing outside, so means internally also you need to consider. For example, you went for a medical checkup, so internal things also they'll cover like blood test, urine test, all these things they are taking because it's a part of your body. So the first one, so this APRP 580 we can apply for pressure vessels, or we can say like all pressure containing the components. So like pressure vessels you can apply. So that's why in the beginning also we seen, right? So we are using as a part of APA 510. So that is nothing but pressure inspection code, pressure vessel inspection code, in service inspection, rating, repair, and alteration. The next one, process piping, that is nothing but APF 570. And the third one is a storage tank, APS 653. So tank inspection, or we call as AST, above ground storage tanks. Then rotating equipments. So if you see the APA website, so they have one certification, APA SIRE, source inspector rotating equipment. So like all the motors are big size equipments, rotating equipments, they also containing the pressure. Okay. Then boilers and heaters, so your boilers and heating equipments, so and their associated internals as well. Okay. Then next, heat exchangers. So most of the time we are doing the tube inspection, right? During the shutdown, we are doing all these tube inspection activities, like the same components, shells, floating heads, channels, bundles, tube bundles, commonly we can call as a heat exchanger tubes. So all those components, associated equipments. Then PRDs, pressure relieving devices. Okay. So if you notice clearly, these are all like used to be seen in the oil and gas industry, especially in the refineries. So we used to see all these things because most of the places we are maintaining a very high pressures. So you see all these things are related with ASME, like a boiler and pressure vessel code, constructions, and ASME. Even if you want to inspect this walls, so there is some document PCC-1 ASME documents. So more or less like they are all dealing with ASME requirements directly, because API is American and ASME also American. Okay, so which equipments we cannot cover? So you need to memorize all these things, because in the exam they will ask questions directly on this the equipment coverage. Okay, so not covered, the first one is the instrument and control system. So especially if you see the oil and gas industry or chemical industry or process industry, so you have these kind of control units. So like this, right? So they're like chemical engineers. They will monitor everything with the software. So like injection points, so the liquid levels, then pressure levels, all these things they'll monitor with the help of this. But RBA is not covering this particular department. Okay. So electrical systems, so electrical also, so you're not involved in this. RBI is not involved in these electrical connections, because the electrical department, they just provide the required current to run the equipment only. So structural systems, like sometime any like structural supports, all these things. So RBI is not involved in this, because RBI main task is to focus on the pressure containing equipments. These are all like less important areas. So your maintenance department will take care of all these things. Not really required an expertise to maintain all these things, right? Your structural supports, all these things. So not covered by RBI. And machinery components, so like internal components, some of the things, if you found any damage, so when your inspection department will take care, like your NDT companies or AP inspectors, when they found something wrong, so what they do, they'll suggest for the replacement or they'll ask for the repairs. Okay. So however, these systems and components may be covered by other types of RBI. So you're saying you're not covering all these like electrical, the instrumentation, all these things, but who will take care? So other departments, that is nothing but indirectly associated with reliability centered maintenance. So what they're trying to say here, like your maintenance department will take care of all these activities. They will assess the risk level. So for example, if they notice the motor is not functioning and getting too much of heat because of the lubrication issues. So what they do? So this maintenance department will open it up and replace the bearing and apply the couplet or the lubrication, and they will sort out the issue. So this one not required to be addressed by the risk-based inspection team. Okay, so same thing. Just now we seen, right, RCM, same thing. Then who are all target audience to implement this API RP580? So most of the time, inspection and engineering personnel. So if you think these two category people, so one set of people like API inspectors. So they may be like internal department or maybe external. Sometimes the API inspector may come outside, or maybe the owner itself engaging the team, API inspection team. And the owners, they used to keep their own engineering team, like the design engineers and process engineers, chemical engineers, like complete engineering people. So it's a combination of these two set of peoples who are all main responsible for maintaining the mechanical integrity and operability of the equipment. So mechanical integrity means like if you see the AP inspectors, what they do, they will assess the condition based on the inspection reports, and they'll give the assurance. So they'll say like corrosion rate very less, and we can operate. They can extend the inspection interval, right? So what they try to say, like we can operate at that pressure, or otherwise they will recommend to reduce the pressure, which we call as MAWP, maximum allowable working pressures. Sometime if the component got thinning, so they will reduce the pressure levels. Last time operated 100, now they recommend you operate only at 80 psi. So sometimes based on the condition, they can suggest all these things. But how about operability of the equipment? So based on the recommendations by AP inspectors, the owner or their associated engineering team, so they will take all these necessary precautions and they will operate the equipment. Okay, so it's a combination of both inspection as well as operating personnel. So both need to work together. So RBI is not exclusively an inspection activity. So when you think of overall activities, you may feel like sometime, okay, they just are doing some inspection and dealing with inspection intervals, but it's not like that. Sometime they will act like a mentors to the owners or asset integrity teams. Sometimes they will listen to the process people like the plant maintenance people or operating people. So when they give some input, they will listen to that and they will update their programs as well. It's not like only dealing with inspection activity. So they always used to speak with the other departments as well, not only the AP inspectors. They will talk to the NDT department, safety department, maintenance department, operations department, and also sometimes the budgeting department, because they're not only like the single activity, so they may have some constraints on the budget. Sometimes they will elevate the importance of implementing these particular softwares, RBA softwares. Usually they are all very expensive, but they can inform to the management to invest to get the benefits of this RBI. So RBI requires the involvement of various segments of the organization, such as engineering, maintenance, and operation. So three departments: engineering, maintenance, and operations. So maintenance is like more or less related with this RBCM operations. So they will give some inputs for your risk assessments. So they tell you when the equipment went to highest temperature or highest pressure. So they can give the valuable information to get a better results through with your risk assessments. Okay, it's a kind of teamwork. So implementation of resulting RBA product. Finally the end product. Most of the time we will say the RBA end product is nothing but inspection plans. Same like a doctor. So the final conclusion is, so you will say when will be the next appointment. So you are checking the reports. You are saying, okay, no need to come. Now your problem got cured. That is one thing. Or sometimes they'll say, now it's in a better situation, so no need to come next week. So you can come after 3 months. We'll see the report again. So something like it's a product, final product is a kind of inspection plan. And sometimes it can be a recommendation or it can be a mitigation activities. Like the doctor will ask you to take less sugar, less salt. These are all like some kind of mitigation activities. And sometimes recommendation, they ask you to run daily morning 1 hour and night time 1 hour walking. Okay, so it's a combination of these things. So you can see here, so you need to assess the risk assessment process and give the risk ranking. Then you have a inspection plan. If the risk levels are very high, then what we do, we can reduce the inspection intervals. For example, if the patient condition is in critical stage, so the frequency of the doctor's visit will increase. So doctor will check every 1 hour once. If the patient condition is in stable condition, so maybe he will check only daily once, only during the rounds. So that's what, like based on the risk level of risk ranking level, so we can reduce the inspection intervals. And mitigation, so sometimes they can control certain things by injections or by some additional protocols. They can mitigate the risk levels, and if the condition improve, they will reassess, they will reduce the dose levels, right? That is what a combination of RPA process. So you can see here data collection and come up with a risk assessment, then give the risk ranking, then implement the inspection plan. If level of risk is very high, then the inspection interval is less. If the risk is less, the inspection interval is longer. Then sometime in addition to that, they will try to mitigate the risk level, then reassess, then finally update the records. So you can see here, so they can go in a systematic way. So they'll check everything step by step, identify the relevant threats. If yes, then evaluate the consequences, evaluate the likelihood and the consequences combinedly we call as a risk. If it is a high risk, if you see the software companies, if they think like a immediate risk, so there is a chance of removing the employee, immediately they'll start searching for other companies. If the risk level is low, then just identify the mitigations. So what do? He will frequently visit the manager, he will talk to them and try to give the timely updates. He'll try to give an impression in front of the manager that he is dying for the company, right? So these are all like required mitigation activities. Then finally, so if the threat is reduced to minimum, then you will be happy, like bringing the situation under control. If it is a high risk, so immediately change to the another plan. So you see here, RBI is a combination of all these things: preventive maintenance or predictive maintenance, inspection, methodology, then repair. After repair, again collect the data and update to the RBI. Then asset management. Then sometime your IT department also will get involved. So you are giving the data, you are asking them to update all the softwares, right? Then inspection plans. So that's why the RBI requires the commitment and cooperation. It's not like a one person activity, so it's a combination of team. So that's what, not a single person involved in RBI, so it's a teamwork. Okay, so this is about scope.